Hello all. So in last class, we already discussed about the need for nonlinearity, where we have seen that given this XOR problem, there is no line that can perfectly separate between this two green and red points, right? Whereas in case of OR problem, we know that three of the data points are 1 and only one is 0. So a single line can perfectly separate it. And same is the case here, that here it's perfectly possible, but here we need some nonlinear boundaries like circle here. Right? So there is a need for nonlinearity. So now let's slowly transition ourselves from this harsh thresholding that we were doing in case of perceptron. So let me just write that again. That in case of perceptron, what we are doing, we were saying that our predicted output y should be, or let's say y cap should be 1 when our summation, I'm not taking bias, so summation of from I equals 1 to n wi xi and plus w naught. Let me write w naught outside, should be greater than or equals to 0, and 0 when this summation is less than 0. That was our thresholding, or we can say our function, right? Our output function. And if we bring this w naught on the other side, then we can say that this weighted summation of inputs should be greater than or equals to minus of w naught, or minus of w naught can be also written as bias b, right? So this is where this bias b is, that this is equals to minus of w naught. And here, since we are taking just one feature, so one weight, so we can also write this as just w1, right? Just to be precise with our notation, that this is our w1, sorry, w1, and we can also write x1 if we want to, right? So this is x1. I don't know why this is happening. This is x1. Okay, w1 x1 plus w0. This is our bias term. So we know that there is a harsh thresholding that happens at this b equals to minus w0. That is when this value equals to exceeds minus w0, then there's a harsh thresholding. So let's say we are analyzing a data, a real life data, let's say is a salary of a person per annum in thousands, okay, 100,000 or okay, 100k, 200k in US dollars, 50k and so on. And there is an output that whether he or she can buy an iPhone or not. So whether he can buy an iPhone or not by 1 and 0. 0 means he or she cannot buy. Okay. So let's say we have to analyze this. So, and let's say we are getting this thresholding as, let's say, 50k. So we are saying now that all the persons whose salary is above 50k, or let's say include 50k as well, 50k or above, we can buy the iPhone, but less can't buy the iPhone, right? So what about people who has salary of 49.99k? We will say answer should be 0 because our thresholding is at 50k, so he or she cannot buy. And same holds for salary that is 51.1 or 50.1k, because we know that our thresholding is at 50k, right? So he can buy buy us an iPhone, right? So this is what the problem is, that we are having a really harsh thresholding, but this is not the case, right? Even the person with salary just above, that is 50.1, cannot buy, right? So how we can tackle such a problem? And such a problem can be tackled by a smooth transition, right? So such a function which provides such a smooth transition for us is called a sigmoid function. So now let's see some of the properties of this sigmoid function, that how it's working. So let me just erase some of my writings and also erase everything on the slide. Now let's see again that what we are discussing. So here, for just to avoid the confusion, I'm just writing w1. Okay, let me just have a little bit not so bold fonts. Okay, this will be fine. W1, and let's say we are having just one feature which is salary, so let's just write x1, just to be precise with our notation of w1 x1 or summation wi xi, right? And w0. So let's say our w1 and w0 are fixed somewhere, which are the parameters that we have to learn. Let's say it's 0.5 and w0 is fixed at something 2. And now for all the inputs x, right, we will have a range of x that we are giving, and we will get some output y. And you will notice that if we have the sigmoid function, our output always ranges from 0 to 1, which is good, right? So rather than having just 1 and 0, we will get some number between 0 to 1, which will give us a probability as well. So it can be interpreted as a probability, right? Which is a good thing. So rather than saying that this person cannot buy a car, we will say, sorry, buy an iPhone or car, any example we can take, right? We will say that it has a 0.5% chance of buying a car or iPhone, and it has 0.6% chance. So we are giving some probability that we are having some confidence interval or confidence score, not interval, but a confidence score that whether this person can buy an iPhone or car or not. So that's where this sigmoid function can help. But now let's see some properties, some mathematical properties of this, that for fixed values of W1 and W0. So of course, these are the parameters that needs to be learned. So we'll start with some random thing. So we'll see in the learning algorithm that how this will learn. But as of now, let's say if this value of entire W1 x1 plus W0 is so high, let's say it's tending to infinity, then what will be this thing will be 0, right? Because it's e power minus infinity, which is 1 upon e power infinity, and 1 upon infinity is 0, right? Then we will get 1. So you will see that for higher values, right, we are getting 1. And same if this is on the negative side and very higher values, that is minus infinity, then it will tend to e power plus infinity. So if we plug in this function 1 upon 1 plus e power plus infinity, which is 1 upon infinity, right, tending to 1 upon infinity, and which tends to 0. So you can see that we are getting on the left extremum we are getting 0, and on the right side we are getting 1. Here I am just plotting between minus 10 and 10, that we will see just in our hands-on session, but in general it's lying between 0 and 1. And when this is 0, we know that e power minus 0, which is e power 0, is 1. So it will be 1 upon 1 plus 1, which is half, right? So we are getting perfectly half, right, at 0.5 when our value is 0, right? So whenever this entire value is 0, so don't get confused with this sigmoid of x and x. This is like, you can consider it as like wx plus w0, okay, with some for some fixed values. But this values, this ranges are for this function x, okay, because we know that our w1 and w0 are fixed, and we have to do this. So here I'm just writing x, and this is sigmoid of x, which is just taking one parameter x, okay, as a variable, one independent variable x. These are just the parameters, okay, they are not the independent variables. So now let's see some hands-on session, that how this function is behaving and how to plot such a function in Python. So for that purpose, I will like to go to the Jupyter notebook. So let's go there, and I'm just importing for now the two libraries that we will need thoroughly for this purpose. So it is just numpy snp, and we are just also importing this matplotlib pyplot splt, and I'm just running this. So now let me just write this function as well in mathematical term. So let me just make this cell as markdown, and I'm just writing this function. So I'm writing this like step by step, so the video might be longer, but you can watch it in a higher speed. So we have two parameters, which is w and b. I'm just writing w and b as of now, but you can also change it to w1 and w0. So it will be great to have practice with both the notations so that it can be useful. And the input is x, okay, so just one independent variable I'm saying again, and this is equals to, we have to write the fraction, right? So this is fraction of, first fraction will be just 1, and second fraction will be, so the numerator and the denominator will be 1 plus, what we want is e power, sorry, oh, I don't know where the power is, strange. Yeah, here. So and e power, and again we need the braces. So for e power, we are gonna write as minus of and we will need wx plus b, I guess. And I think we are missing one brace, closing braces. Okay, so yeah, perfect, looks fine. So it's just the let me just zoom in a bit, that's better. So now what we will see is that how we will define this in Python. So I'm just defining this sigmoid, and we have three things. Okay, first is w, second is b, and the third is x that we want. And what it should return, it should return something like 1 upon 1 plus this entire exponential term. And for this exponential term, we are using this numpy function. So numpy has an exp function, if I'm not wrong, and this will have this w multiplied by x, simple, and obviously inside we are missing our bias term. So this is our simple function. Now let's call this function and see if it's perfectly working or not on our known inputs. So let's say so you have to give in the same order w, b, and x. So let's say our w is 0, our b is also 0, and x doesn't matter because it's 0, then it's e power 0. So it should give like 0.5. I hope it will return 0.5. Yes, perfect. So x doesn't matter, you can verify it, that because the entire term is getting 0. So right, but now let's give some random inputs for w, b. Let's say b is, I don't know, 6 and x is 5, and we are getting some value, right? It won't exceed 1, right? So it's we are getting 0.999 whatever. So the function looks fine as of now. Now let's try to plot this. Okay, and for plotting, so we need range of x, right? It's not like for any fixed w and b. So let me just write first. Let's say we are fixing w to 2, and let's say we are fixing b to minus 0.8, any random number, doesn't matter. Now I'm writing range of x, that's why I'm writing capital. So throughout my sessions, I will try to be precise with the notation so that it's not confusing, and the capital letters denotes vectors. Okay, so the x was just a single value, so it was a scalar, but now it's a vector. And again, we have seen in our slide, we are plotting from minus 10 to 10, the range. So what this function will do, that it will just generate a range of values of x between minus 10 and 10. And how many values you need? Let's say we need 100 values. You can also plot 1000, doesn't matter, but let's say we need 100 values as of now. So this is what this function will generate. You can just directly see this, that how this x looks like, by just calling print x, and you will see a range of values between minus 10 and 10. So you can see, and there is a step. So it's also in this order, right? So since you have to break this minus 10 and 10 between 100 values, it will just give, okay, a range from minus 10 to plus 10, both included. So this is just a simple function that you can just look around by just plotting. But now what we have to do is, our output now will be range on. So for a fixed w and b, what we will give each of these points to our function sigmoid, correct? So we will get this, how many we are getting from minus 10 to 10, we are getting 100 values. So we will get 100 different y's, and this we will store in this y as a vector, right? So what we have to do, we have to just simply call the sigmoid and just give our functions in our order. So we know w value, we know b value, and what's our x? This is x. Now you might be wondering that here we are just having a scalar value, right? A single value which is multiplied. This is just a multiplication, right? Simple scalar multiplication, like 2 into 3, 3 into 4 that we do. But here you are calling the same function, but now you are giving a vector of x rather than this simple scalar value of x. So what this will do, so numpy has a really, or this numpy.exponential function. In this, there is a broadcasting function that we have. So what it will do is, it will adjust it automatically. This is called broadcasting in matrix multiplication. It will automatically adjust this value. So what it will do is, it will take single values of x and give each value of y. So it will first take -10 and this values of W and B, right, which we just randomly selected, and it will give first point corresponding to this. Then it will take this value of X and then multiply it with the X and just add it to B, make this operation of exponential and do this and return this value totally and just store it in Y. So it will be another value of Y corresponding to this value of X. And it will continue so on until the last value. So let's try to see how the Y looks like now. So let's see how Y looks like. And it will be also 100. So you can see it's an array. So it's type of array, and let's type in the shape of it. Sorry, I need dot. And you can see that it's 100, right? And the shape of X is of course 100 because we generated 100 values within -10 and 10. So that's what we are getting after this. And now let's try to plot this. So now we have range of values, right? We can't plot just with single value. Single value will be just point, right? Just one singular point, which we can't plot. We need range of values. For range of values of X, what is the range of values of Y? That's how we need, right, to plot. This is basic algebra, you can say, from our high school. So what we need, we have to plot x-axis, y-axis with X and Y, and we'll just say plt.show. So this is how simple it is in Python to plot everything and visualize. So you can see simply, this is the same function that we have seen in our slide, right? The same plot. I just imported this plot from here only. So you can see this is ranging from -10 to 10 and giving a smooth graph like this. Now let's try to change the values of W's and B's. Let's say we are doing it as -10. Now W is a slope parameter, right? So if we do it negative, then what will happen? It will invert its shape, right? It will be like, you can see previously it was like this, now it's going from like this. So that's how the slope, we know that this is, the line is like Wx plus B. So Wx plus B, W controls the slope and B is like an intercept, right? And so what B controls is just shifting of this function entirely in this direction, in the horizontal direction, correct? Now let's try to visualize this a bit more. Okay, so for this I am gonna use this is the function. So I already pre-wrote all this stuff. Now this is the same thing that we had until now, but now what I am trying to do is trying to use some widgets. Okay, so Jupyter Notebook has inbuilt this function. So let me just write all this stuff again so that you can follow rather than just viewing it. So I'll do a little bit of back and forth, but bear with me. So I'm just using this. I'm just copying it here and pasting it. So it's just widgets which is needed for just sliding. Okay, we'll see what why this is needed and so on. And now from this we are using this interact function. So let me, this I'll write. So interact function we are using, and what we need is we have to have this sigmoid function with whom we have to interact with, and we will give different values. So what is the value of X, W and B? In any order you can give, right? So but you have to just specify. So I'm just giving in our order that we created. I think it's W, B and X. So let's say W. So what's the W value is? W is, we are just using integer values for W as of now, but you can also write float slider. It doesn't matter. So it's really simple. You have to just say what's the minimum value it should take, maximum value. So the goal of doing this is like to do something like this, that when we change our W's and B's, our graph changes, right? So you can see when the W is negative, and when it's positive, it totally inverts, right? It might be delayed a bit to invert, but it's inverted, right? So that's how it works. So just we have to give the initial value. This will, the values it will start, and you can just drag and drop using this. And that's what the use of this library is, this IPython, which is inbuilt, right, in any Python 3 module that you're going to use. So we'll just say widgets, or better I will copy now at least the widget one. So I'll show you that you can also use float slider, it doesn't matter. Widgets dot, we have used integer slider there. Let's try. So if you just press shift and tab, there will be a series of suggestions that you will get. Okay, and also there is a definition that you will get. Okay, so I'll just write dot, and you will get a lot of suggestions. So here we used integer slider, but you can also use float slider. So I'm just now I'm showing you float slider. What should be its minimum value? -10. So let's write -10. Minimum should be -10 or 10.0 because you're using float, but doesn't matter. Max should be, let's say, +10, and our initial value should be, let's say, 0. Correct? So that's how it works. Now I will just copy this for rest of them for B. So I'll just change this to B now. Also the same range I'm putting, and I'll also do the same for X. Correct? Now if I'll do this, let's see what happens. Just let's try to. So it's just giving the value of our function. It's not plotting, right? So depending on the change, what we do in W's and B's, we will get some different values here, right? It's really small value that we are getting. But of course, because in our sigmoid function, what we have written until now, we just need to return the values. So it's just returning the values. But in order to plot this, what we have to do, we have to do something else as well, right? And how we can do that, let's try to see that. So what we will do is, in this function that we have done, we will write this, that rather than taking just rather than giving this, okay, what you have to do, you have to take range of values of x and plot this. So we will call this function then, which has inbuilt plotting functions. So what we will do, we'll just write, let's say our x is ranging from -10 to 10. Okay, then we have to plot okay, and we have to say plot.show. Correct? And what we have to do here now, we have to write wx plus b, which is our y. Correct? And we can ignore this if we want. And now what we have to do is, we have to say just plot.show. So let me just run this function again. And now let's go here where we are using the same sigmoid function to interact with. Now let's see if it can plot. Yes. So all things are 0 because we initialized all values to 0. But if we move the slider now, okay, it started. So you can see values between 0 and 1. So you can see, let's say for fixed value of x, okay, what's the function of b? So as I said, b will be just moving our function in horizontal direction. So you can see b is just shifting our function in this direction. Whether w is controlling the slope, that if it's negative, it will invert it totally. And if it's positive, it will be doing the other way around. Correct? So that's how this interactive function looks like and works. So here we did nothing, but we just used the plot function here. So it doesn't matter that much. And this is just the input value, which won't affect now because we are taking the range of values, right? So we can also ignore this if we want to, because this is, I think, not needed anymore because we are plotting a range of values now. Sorry, where is x1? Perfect. So we are just ignoring and rerun the function and then just rerun this. I think we don't need x anymore. X will be taken automatically from the range of -10 to 10. It will be plotted. Correct? So that's how the function looks like. That's what our sigmoid function is. And now let's get back to our PowerPoint again. And we have seen this takeaways that now we have smoother decision boundaries, which is better. So that's suitable for our real world applications. The other thing is output is no longer just 1 and 0 or yes or no, rather some value between 0 and 1, and this is our probability, right? Interpreted guess probability. And it's the best and most important thing is it's differentiable at W naught, and we will see how this differentiability will work, right, when we will see our gradient descent in the very next lecture. So stay tuned, and that's all for this video. Thank you.